Hey there, astrophiles! Have you ever wondered how the universe might end? Maybe you've seen the movie Don't Look Up and thought, well, it could happen like that. Or maybe you've seen Interstellar and thought, hey, that ending was totally unsatisfying. How will the universe really end, and will humanity be here to see it? If you like optimistic science and tech stories, you'll probably want to look away now because this is gonna get depressing. So buckle up. The heat death of the universe isn't exactly a fun topic, but it is one of the most fascinating. When we talk about how old the universe is, we're talking about the age of the universe since the Big Bang. The current estimate is 13.787 billion years. And when scientists say the universe is expanding, they mean everything is moving away from everything else at an accelerating rate. That means the universe is only going to get bigger, which seems pretty neat. We get more stuff all the time. But it also means that if you were to continue extrapolating the current trends, everything would eventually drift so far away from everything else that the only thing you could observe would be the stuff right outside your window. Eventually, you'd be completely alone in the universe. But that's not the end. Oh no, not by a long shot. If our sun is anything like other stars, it has about another 5 billion years of healthy burning gas fusion left in the tank. After that, it'll expand into a red giant, engulfing the inner planets, including Earth. So even if humanity somehow manages to survive the next 5 billion years, we won't be doing it for long. So what happens after that? Well, according to our best models, the universe will continue to expand, stars will continue to form and die out until every single star in the night sky goes out, leaving the universe completely dark. All that will be left are the remnants of dead stars and the black holes that lurk in the centers of galaxies. This is where things get weird, because these black holes aren't like your run-of-the-mill black holes. They're supermassive, millions or even billions of times the mass of our sun. And as the universe expands, these black holes will drift further and further apart. But here's the thing, black holes don't just pull in matter and energy. They also emit a tiny amount of radiation known as Hawking radiation. This radiation has a temperature associated with it, and the hotter the black hole, the higher the temperature. Since black holes can't be bigger than the size of our sun, these supermassive black holes must have started out bigger. In other words, they've been cooling down for a very long time. Okay, let's take a break from doom and gloom for a moment. If you're enjoying this video, be sure to check out our podcast SCI Show Tangents. Every week, we bring you a new science-themed comedy adventure featuring a rotating cast of your favorite SCI Show hosts. New episodes premiere every Tuesday, and you can get them exclusively on a streaming platform. Anyway, back to the heat death of the universe. As the supermassive black holes continue to cool, their Hawking temperatures drop to absolute zero. There's no getting around this. It's just the way physics works, but here's the kicker. When the black holes reach absolute zero, they don't just emit no heat, they begin to absorb any heat they come into contact with. And as the universe continues to expand, they become colder and colder. Eventually, they'll start sucking in the very fabric of space-time itself, collapsing the universe into an infinitely dense point. Some physicists think that at this point, the Big Bang would happen again, restarting the universe. But others aren't so sure. They think the universe would simply collapse in on itself before expanding back out again. Either way, all the work we've done on our spaceships and our rockets and our telescopes would be undone. We'd go from being light years away from everything to being light years away from nothing. Maybe we could save ourselves by escaping into the vastness of space. I mean, the theory of general relativity says that wormholes are possible, so there may be some way to travel through the universe and find another one to wormhole too. Too bad those pesky physicists went and discovered that wormholes would likely be extremely unstable and dangerous to traverse, or they'd require negative masses to keep them open, something that doesn't exist in our universe. Sorry, folks, but it looks like our best option is just to stay here and face the inevitable heat death of the universe. So grab a cup of tea, a nice blanket, and a good book. You're gonna need them. Many scientists believe that the heat death of the universe is a real possibility, but some disagree. They say the universe will never truly die. Do you agree or disagree? Let us know in the comments below.